for now, we have the linguistics of programming. Stage is yours.
All right, thank you. So, yeah, we're going to talk about some parallels between linguistics and programming, and of course this is not a new idea to connect these two, since language is right there in programming language and all, and people have written about this over the year, including a rather raucous dialogue at last year's Onward. But I'm going to try to do something a little bit different than most of the previous discussions I've seen, and instead of just sort of drawing philosophical parallels, I'm going to try to make the point that there are very concrete, specific things that we can take from linguistics and use to our own ends in ways that help us. And so if you think about, what do we do in programming languages and software engineering research? Well, we think about how software is constructed. We talk about the social side of that, the technical side of that. We think about how people use and produce code. We think about what properties a particular piece of code might have. Maybe it's buggy, maybe it's data race free, maybe it's both. We think about how code interacts with other things that exist in the world, like comments, either in the code or in a bug tracker. We think about design documents. Natural language specifications is something many of us are working on now. We think about how people comprehend and understand code. We think about common properties that a programming language or group of programming languages either have or might have. And we think about what programs mean, right? And not just in terms of the computations that they express. And if you do a little search and replace here, you end up with a pretty reasonable approximation of what linguistics is about, right? They care about where language comes from, how it comes to be. They care about how people use and produce language. They care about properties of a particular utterance of some language, right? Are there pragmatic phenomena at play? Are there presuppositions? They care about how language interacts with other things, like when I point at myself or at you and the context this matters in, because if I turn around and say you, I'm pointing at the wall instead of you, right? They care about how people understand language. They care about typological properties, properties that are common across many or all languages. And they care about what language means. What do these words that I'm saying right now mean to you, and how do you know what they mean, right? So if we take a very cursory overview of some major areas of linguistics, we can see a lot of familiar terms, right? Syntax. Programming languages have this, and it's not even Chomsky's fault. Semantics. Hey, our programs mean something too. Pragmatics, right? We maybe don't pay enough attention to this question of why did I write this code instead of that code? What's implicit in this code but still supposed to be obvious somehow? There's aspects of morphology, right? James and Robert made this nice point about pass by reference, having a bit of a flavor of being an accusative case. There's psycholinguistics and neurolinguistics, right? We have people who stick people in fMRI machines like Janice Sigmund and collaborators and see what happens in their brain when they're understanding a piece of code, right? And there's even orthography, writing systems. Anybody ever dabble in APL? Couple people, yeah. Unicode in your code, yes, yeah. So we'll come back to that, because that actually, even though it seems a little superficial, it comes back and we'll talk about it later. So there are some deep commonalities here, right? So PL and SE and linguistics, we all kind of care about what things mean, different things, and how they're used. And we generally are looking for explanations. Why do they work this way? How do they work? And we largely spend a lot of time staring at linearizations of highly complex structures with non-trivial, context-dependent, and often socially constructed interpretations, right? And we care about how people use either code or language to communicate with multiple audiences. And for code, this is not just our compiler, but also our future selves and our peers who are supposed to understand something about what we did, right? It's not just for other researchers that we want to prove how smart we are, right? So there's enough similarities here between linguistics and our fields that there are a lot of ideas and tools that I would argue not only can, but should inform PL and SE research. And I think if we don't take advantage of that, we're doing ourselves a disservice. Before I get into details of concrete things we can look at transferring across these boundaries, I want to fix a common misconception that I run into very often, which is that linguistics and computational linguistics and NLP are not the same thing. They are three closely related areas, but they're looking at very different problems, right? So most of us here are in computer science or software engineering departments. A fair number of us are doing software development in industry. And so it's very easy to get this impression that like, hey, you know, these things that happen with neural networks and all that, that's linguistics or computational linguistics. But most linguistics isn't even computational because it's about how people use language, right? And in particular, most linguistics has absolutely nothing to do with LLMs, right? So people do experiments from time to time to say, can we use an LLM to simulate what a person might do in this kind of situation? And with a couple exceptions, the answer is basically no. They don't work the same way as humans do, right? So we're not going to say anything more about them today. Everybody here already knows what they are. So we're going to talk about other things that you might not be aware of. And just for context here, we're not going to talk about everything in the essay because we don't have time. But even the essay is only scratching the surface, even though there's 191 references, right? The only thing I've written that has more references than that was my dissertation, right? So even though there's that much there, we're still only scratching the surface, right? So there's way more than what I'm going to say today. As far as what I am going to say today, we're going to kind of take a tour of a few different levels of possible interaction, from some higher level, how do people interact with some of the things we might say or do or try to say or do. We're going to talk about some ways of looking at data that comes out of developer processes that we could probably profitably go rating the linguistics literature for. And we're even going to talk about low-level sort of fiddly things about what can I do to make my compiler more interesting or flexible or have other advantages there. So there's stuff at all different layers, all different flavors of TL and SE research. So we're going to spend a fair amount of time talking about pragmatics. So pragmatics is the study of intended but unstated meaning. These are things that we are meaning to communicate, but we're not explicitly saying, right? So like a conversational implicature is, if someone asks me, did you get that code working? And I said, oh, I spent last week in debugging hell. I'm kind of leaving it implicit, but you would gather that I didn't get the code working, right? But it's only implicit because if I had kept going and said, but I got it working in the end, it would have been different, right? So there is somehow this implicit communication. There's this notion of deixis, right? Different parts of text can refer to other parts of text. And we do this all the time when we write code comments. The loop below and the loop above, right? If you move the context of that comment, it doesn't mean the same thing anymore. Or presupposition, right? This is a method that is called when the foo component does X, Y, Z. Well, this only makes sense if there actually is a foo component, and there's still a foo component, nobody deleted it, and somebody actually calls the foo component, and that it does the other things that we talk about in this comment. And if any of that changes, then the meaning of this thing changes as well. Or scalar implicature, right? If I say that this library is acceptable for our purpose, well, why didn't I just say good? If I didn't say good, it's probably because I don't think it's good. I think it's only acceptable, right? And so this turns out to have a bunch of implications for how people interact with text that we might give them. So here's an example that might be relevant to those of us who do user studies about, say, formal methods kinds of things. So there's this thing called a Hereford disjunction, where you're asking people A or B, but it's a little bit weird because one of them implies the other. And so if you ask people if A or B is true, they will read this normally as being like a little bit off. And so they'll try to fill in, like enrich this so that it makes more sense that you're asking them a contrasting question between these possibilities. So here's a sort of a PLSE analog of a famous behavioral economics example. Some researchers asked a bunch of people, given that Aaron likes Python decorators, is it more likely that Aaron is a Python programmer or a programmer? And now most of us would see this and say, like, okay, well, this is in contrast, like an either or. So they probably mean like Python programmer or a non-Python programmer. But they like decorators, they know about decorators, so they're probably a Python programmer, right? Except that's not actually what the people who designed the original experiment meant. They meant the equivalent of, is the probability that Aaron is a Python programmer greater than the probability that Aaron is a programmer? And the answer is, of course, no, right? But this is not the way most people interpret this question, because the disjunction is a little bit funny, right? So this is kind of a roundabout way of saying that a lot of us are increasingly, and this is good, starting to do more human evaluations. We're asking people these questions, but there's really subtle phenomena that it would behoove us to know about as we're designing these things and be aware of, that we can ask questions that don't go across to other people the same way we mean them. And this is especially true for logical words, or and similar logic-related terms. Turns out they're the source of triggers for a lot of these kinds of extra enrichments. So one of the really classic examples here is conjunction buttressing, right? So further supporting structure around a conjunction. And the classic examples from linguistics are things like, I took out my keys and opened the door. And this is usually interpreted as, I did these things in that order. I first took out my keys, and then I opened the door, probably using the keys, right? And as opposed to being sort of simultaneous, right? Or even happening in the other order, like I opened the door and then went inside and took out my keys. Or I got on my horse and rode off into the sunset, right? There's a strong implicature here, it's not explicit, that probably you first got on the horse and then rode off into the sunset, instead of, you know, riding off into the sunset on a dune buggy, getting home, and then getting on your horse, right? But these are things that are implicitly understood when we speak this way in English, and similar phenomena occur in most other languages. There's also, if I'm going to blend the boundary between pragmatics and semantics a little bit, this notion of a thing called a habitual sentence. So it's a sentence that is implicitly expressing a recurring state of affairs. Like if I say, I read the archive mailing with my coffee in the morning, I'm not explicitly saying this always happens or that this happens daily, but this is the intended reading, and this is what most people understand if you say something like this. So what does this have to do with us? Well, so Ben Greenman and some other folks wrote this really nice paper last year where they looked at what mistakes people make translating English into linear temporal logic. And if you look at the data, which is what I've spent the last few months doing since I wrote this essay, it looks like there are some mistakes that are tied to these pragmatic phenomena, right? So one of the common things that happens is people leave off a next operator in temporal logic, which says this part of the formula happens later than what we're looking at right now. And this often happens right after a conjunction. So if you were to try to translate, I took out my keys and opened the door, the way we typically understand it, you would say, I took out my keys and eventually, later, I took out, or I opened the door. And people leave this off. So this seems like an interesting parallel here. And there's also this question of people leave off a top-level always operator that explicitly says this always happens. And that also corresponds to the difference between interpreting this habitual sentence as the recurring state of affairs versus just something that happened once. So let's keep going. Let's think about some other areas of linguistics and what they might have to teach us. So let's talk about language acquisition. So linguists, no surprise, have spent decades studying how people learn languages. And in particular, they've even broken it out into interesting differences between, obviously, the first and second language have some differences, right? Because the second time around, we've already got a language to start with. But even learning the third language turns out to be different from learning the second in interesting ways. And there's a little bit of evidence that even going to the fourth language introduces some new stuff to the mix, right? And they've done a lot of experiments studying cross-language ordering and how that affects outcomes, right? So someone who's a native English speaker learning French is going to end up with their knowledge of French in a different state than someone who starts out from German and learns French. And if we start learning more languages, well, if you learn English and then German and then French, you're going to end up with French in a different state than someone who starts with German and then learns English and then learns French. Even though you're learning the same set of languages, the order turns into yielding different results, different kinds of mistakes, right? There are studies of typological differences and how that affects learning. If you're learning a language that's sort of in the same language family as something you already know, this makes certain things easier and certain things harder. And this should be familiar to anyone in this room who said something like, if you learn one functional programming language, you can learn another one more easily, right? That is, in fact, exactly that kind of argument. And they've done studies of intermediate stages of progression in learning their second or third language. There's interesting phases to call out: the early phase, where they're really still figuring things out, and then progressively later phases. And so we study how people learn programming languages too, but these are not experimental setups that we've done, as far as I can tell, and I've looked. Not to say that it's totally trivial, because there are some differences, of course, between natural languages and programming languages. How many of us speak at least 5 natural languages? Yep, that's what I figured. How many of us can productively write in 5 programming languages? Most of us, right? So we dabble more in programming languages than we do in natural languages, right? So that does complicate, finding people to even do these kinds of setups. But let's take this seriously, right? So let's assume that natural language acquisition and programming language acquisition should more or less be pretty similar, right? Maybe there are some differences, but let's assume that they're pretty similar. So let's take that perspective and let's look at a language acquisition study that we've already done and see how that lines up with what the natural language acquisition literature would say. So let's look at what was at the time a little bit of a controversial paper. Yes, exactly. So Stefan Hannenberg wrote this paper in 2010, where basically he asked a bunch of students who had just taken intro programming to learn either a typed language or an untyped language. And they're the same object calculus, but either a typed or untyped version. They got an IDE. I'm pretty sure they got a debugger, right? So pretty comparable experimental setups, other than type checked statically or dynamically, and asked them to implement a parser. So what happened? Well, the two groups had basically the same rate of bugs, right? Basically the same rate of bugs, same kind of bugs. But the typed group took longer to get something running, right? Not necessarily to get something fixed, but longer to get to the point where they could even run test cases. And so this was interpreted as type systems failing to show benefits. And of course, it made lots of us who work on type systems very sad, because we felt misunderstood and misrepresented. And there was all sorts of discussion at the time about this. But let's take a step back and let's say, what would the natural language acquisition literature tell us to expect here? So in that context, this is actually exactly what we would expect. The early stage of learning a new language, when you already know some, and this is true for L2, L3, and so on, the initial mental model for the new language you're learning is going to be a garbled version of a language you know, right? This is why, when I was first learning German, right, one of the things English speakers struggle with in German is word order. Where does the verb go in the sentence, right? Because in English, we stack them all together at the front, as in many other languages. And in German, if you have more than one, something gets jettisoned to the end of the clause or the end of the sentence. So what this means is basically, in this context, all of these participants still basically had a mental model that was Java, right? They had a short tutorial, but that's not enough to majorly change someone's mental model of what an object-oriented program does. Now, you're probably saying, like, OK, yes, I mean, they're both object-oriented languages, and that's fine. What does this have to do with the typed versus untyped distinction? Well, type checking at the level you see in CS1 Java is a grammatical property, right? It's grammatical agreement between this part of the program over here and this part of the program over here, needing to be consistent with each other. That is a context-sensitive language recognition problem, and many natural languages are mildly context-sensitive, right? So this agreement actually is a grammatical property in how people think about relating distant parts of some sentence, which means, in a very literal way, the untyped group is effectively trying to write typed code just without the aid of a type checker. So this is not a group of people who are going to instantly switch to taking advantage of whatever flexibility or liberties dynamic type checking might allow. They're mentally really trying to get these different pieces to agree. But only the typed group was actually slowed down. Only the typed group has somebody stopping, and every time they made a mistake saying, hey, wait, I think you actually meant dame instead of Dane, right? Or something similar to that, right? So you might learn better in that way, but it would take you longer to get your point across, which is what happened here, right? So I want to emphasize, I'm not trying to knock this study. I think this was still a study very much worth doing because it shows, hey, here's a concrete example of natural language acquisition and PL acquisition behaving equivalently, behaving similar ways, right? So that maybe is not the intended original purpose of the study, but this is what I get out of it now, and I think that's really cool. The essay talks about a second example, looking at another somewhat contentious paper on the intuitiveness of programming language syntax, right? And so in that paper, one of the things that they found was if all the keywords are English keywords, then great, people find this more intuitive, and you know why. I think the best example for this is actually an anecdote from Felina's splashy Onward keynote last year, where she told this story of a student learning Python, got an error message, they read it aloud to the instructor, and what happened was they read part of the message, then paused, and then continued onward like they had maybe skipped a word or something. And it was a comma that they had skipped, because punctuation in natural language is not meaning-bearing. So moving to a setting where those characters do bear meaning is a significant change, right? And this is parallels to people learning language with a new script, right? Also, I didn't know this at the time I wrote the essay because it was, of course, only out later, but there was this very cool splashy paper yesterday where they took natural language teaching pedagogy and applied it to teaching of programming languages and got some really cool results. So you should totally check that out. All right, so on from language acquisition. Let's talk about looking at traces of conversations from software contexts. Right, so the past 15 years or so, software engineering folks have really spent a fair amount of time looking at developer mailing lists, discussions on bug trackers, discussions in Slack about what was happening with their software. Turns out this is something linguists have looked at for a lot longer than software engineering people. Right? So there's this large area called discourse analysis in linguistics. And it's the study of how longer linguistic utterances acquire their meaning, with a particular emphasis on discussions, interactions, and exchanges between different groups of people. And this is something that linguists have been studying in earnest since the 50s, and if you go a little bit further for the early signs, they go back to the 20s. So they've been at this for a long time. And this deals with questions that the software engineering folks are now reckoning with in the software engineering context, right? What is the relationship between this text, the context in which the discussion is occurring, the power differential between people involved, how much people can remember, these sorts of things. And this is really exactly the sort of thing people in SE are now starting to look at. I shouldn't say now starting. They've been doing this for a good bit over a decade now. But they are really looking at this in developer chats, issue tracker chats, mailing lists, and these other sources where developers discuss what happens with their software. And that particular context is called computer-mediated communication in some areas of linguistics. And they've been looking at that since the early 90s. And they have rich studies now for how things like gender or race, sexuality, power positions in a project, how those factors affect how people participate in these discussions. And so these are specific topics that are now showing up in research in software engineering. And I have a hard time thinking that there's nothing to learn from this larger body of work that's a little bit older. All right, so I did promise that I would have something to say about stuff that's not people, right? Because many of us implement compilers and runtime systems, and so we're interested in these little fiddly bits. So here's just one taste of something. So linguists, of course, spend a lot of time dealing with grammars, right? They deal with syntax, one of the major research areas in linguistics. So there's this thing called a lexicalized grammar, which is a style of grammar where instead of recursively specifying a bunch of fixed set of categories, right, the non-terminals in your context-free grammar, You have a few base things like noun phrases, articles, adjectives. But anything more complicated than that, actually you give just a description for how each word combines with neighboring words. So you could switch between prefix and postfix and infix choices for plus, for example, just by giving slightly different grammatical types to the plus operator, right? So in this notation, the slashes lean in the direction of the argument. So prefix is going to look to the right for its first argument, and after it gets that, it's going to look to its right for a second argument. Postfix is the reverse, and this infix, this one happens to look left first and then right. If we're reading outside in. And the advantage here is that you can add or remove or swap individual entries or their grammatical types as needed. And since you don't need to go out of your way to specify a lot of the sort of intermediate categories in your grammar, if you want something that's conceptually like a wildly new category in your grammar, you just build it up from these almost function types in the grammatical types. And you don't have to then add some new non-terminal and plummet through the rest of your grammar. You just say how it interacts with things that are adjacent to it. And this is very modular in a nice way that has some tie-ins to language levels or internationalization or just experiments with your syntax, right? And there's very general, nice parsing theory there as well. And if you're wondering, okay, well, if we got rid of my context-free grammar, where'd my parse tree go? Well, there's an interface between these things and semantics. And guess what? When linguists do formal semantics, they use lambda calculus, right? Which we're all familiar with. So you can abuse that to get ASTs. So you can say the semantics of plus is going to bind its left argument and then its right argument and give us a plus node, right, with things in the right place. Just as a small, sort of simple example, right? And so wrapping up, there is way more for us to learn from linguistics that is directly applicable to all sorts of things that many of us are doing. We study things that have very strong similarities or analogs to things that linguists have been studying, in some cases for longer than we've been studying them. There are results in linguistics that seem to have direct application to things that we are doing on a day-to-day basis. I showed you a couple examples, well, showed you one and hinted at a couple more where if you assume natural languages and programming languages are similar enough, natural language acquisition research predicts what happens when you do PL acquisition studies. And that linguists face a lot of the same sort of tooling and abstraction and modeling challenges that we do. And they've kind of been doing their own thing for the last several decades. And so they have like a very different suite of tools and techniques and ways of looking at things that I think are, at a minimum, very interesting and I think more probably actually directly useful to us. So please, 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 if you're doing, I don't know, anything in software engineering and programming languages, go learn some linguistics. Minimum, the worst case that happens is you learn a bunch of really cool stuff. And probably you'll come up with at least some new tool or technique or some new way of looking at your problems that maybe you wouldn't have come up with on your own. Right? Thanks.
Thanks for the talk. We have time for questions.
Hi.
Hi.
I actually did study linguistics 40 years ago. And so I was fascinated by your talk and what you do. I mean, there already is actually a lot of overlap with linguistics, not just subject matter, but the origins of a lot of our techniques in terms of parsing, phrase structure grammars, lexicography, and whatnot. Actually, right, BNF comes from Chomsky normal form.
Absolutely.
What we haven't done is the softer side of it.
Yes.
So the fact that you mostly talked about the interaction with people, I like that because I was fascinated by psycholinguistics. But one of the things you just went over very quickly was semantics, which is sort of there in between the pragmatics and the syntax. One of the things that I've seen over the years is that when we talk about semantics these days, it's like ontology and the semantic web, which when you look at it, it's just syntax.
Yes.
It's an encoding of our semantics.
Yes.
And you talked about formal linguists mapping to lambda calculus. Well, kinda, except that's really just mapping to another language, right?
Yes.
The really interesting study is what do languages mean? What do we mean by utterances relative to the real world?
Yes.
When we start talking about programming languages, and especially what I'm interested in is modeling languages and the real meaning of ontologies, that's that mapping. And that, to me, is one of the really interesting things from linguistics, which isn't solved in natural language studies either. But I think we could contribute back and forth on that.
So you're right. Like the connections to what linguists call semantics, and I do mean linguists, not this ontology stuff that NLP people do.
Right.
Right. I didn't talk about that much because I would just be kind of waving my hands and talking about another slightly different variation of lambda calculus. And so I thought it was probably a better use of time to focus on, like you said, the people side of things. But yes, there's a huge literature there, including human studies of how do you figure out what an individual word means in different contexts.
Right. Well, I mean, that was some of the earliest linguists, were looking at individual words before Chomsky in the 19th century.
And it's still alive and well. Actually, I wrote the author response to the reviews for this essay sitting at Experiments in Linguistic Meaning, which is a new conference that is held at Penn every year. Yeah. They're still hard at work and doing really cool stuff.
But I mean, back in the day, Montague grammars were basically denotational semantics for natural language.
Yep.
But again, that sort of begs the question of, is the world really represented by lambda calculus or by mathematics? The meaning of a word isn't the lambda calculus, it's how we relate to the world. And our programming has an operational side, which lets us operationalize some of the semantics, which I think actually makes it interesting in terms of language. Can we think of language also in an operational way, semantically, natural language?
We have more questions. Thank you for the comment.
Hi, thank you very much. That was really great. I really like to see these links being made. I think it's very exciting. I wanted to ask what your view is on some of the differences, because I know there's obviously lots of similarities, but that there are also differences. Linguistics, although there's formalizations, it's getting at something that's a bit more fuzzy, a bit more hard to pin down.
And this kind of echoes what you were asking about a second ago as well.
Yeah.
And it's true. And so in some ways, and so I spent the last couple of years using actually categorical grammars and those kinds of formal semantics to bind natural language to formal specifications. And in that work, I talk about how actually our lives are easier than linguists because we're talking about this program right here, right? It's right there. Yeah. We know what the semantics of the program are. We're not trying to figure out what is a cow? Right? Which linguists are genuinely trying to do because it's kind of like an amorphous, fuzzy concept, right? When does it count as a cow and when does it cross over into being a dog and these sorts of things.
Right. Thank you. Thanks.
Hi, thank you so much for this talk. It was really interesting to see these comparisons between linguistics in the natural sense and in the programming sense. I've been interested in parsing for a while and kind of, both sides of it and whatnot. Earlier in the talk, you asked how many people here can produce in 5 different natural languages, and I don't know if anybody raised their hand, but very few.
Oscar.
And then you asked how many people can produce in 5 programming languages, and I think most people here did because most people can probably at a programming conference can probably produce in 5 languages. So my question is, what do you think of what it means to have fluency or some level of partial fluency or productiveness in a natural language versus a programming language? Because I think there's a reason that I don't know 5 natural languages, but I can work in 5 programming languages.
You did pick up on something that was intentionally a little bit of a rhetorical sleight of hand to kind of get the reaction I wanted, where I asked about fluency in the natural languages and competence in the programming languages. But even in linguistics, this notion of fluency is not a hard and fast thing. And even though for decades, the baseline was, comparing people's language skills against an L1 native speaker. And in recent years, people are actually starting to question even that, if that's really the right baseline or if the baseline should be slightly different. And so that's something people are actively kind of debating. So I don't know what counts as fluent in certainly a programming language.
All right, thank you so
It's a
much.
hard
Appreciate
question.
it.
There's still time. There's more questions.
Hi, thank you for the thought-provoking talk. I wanted to discuss the Java language transfer experiment that you discussed. Couldn't you make the opposite hypothesis based on the language learning that like Java is a strongly typed object-oriented language? My hypothesis would be that people learning a second language would do better with another strongly typed object-oriented language.
You could certainly form that hypothesis, and there's stuff in the linguistics literature to support that as a baseline expectation. Although I will emphasize that that's never the only difference, really, between especially natural languages. So it's always in the mix with a bunch of other confounding factors. But there's some stuff to support that as well.
Okay, I guess I'm asking why did you form your hypothesis as opposed to the opposite one? Like the claim is that the linguistics research would support.
Oh, I see.
You see what I mean?
I see. So the question is what counts as better, right? And the issue is what was measured in that experiment was how long it took them to get something working when they either did or did not have something interrupting them, correcting their grammatical mistakes constantly. And so, when you're talking about like they would do better with types, well, you could make that argument longer term that they would maybe reach competence or fluency faster, but the initial stages are going to still be the same. The initial stages are, it's not exactly the same as Java. I'm going to make mistakes, right? And this is why the knowledge about like the different stages of learning a new language matter, right? And so that's how I ended up with this hypothesis instead of
So
that,
then-
which was maybe valid for like a longer term.
So,
Okay.
Jonathan? No? I have a quick question.
Sure.
Just unlearning came to my mind.
Unlearning.
Overriding concepts, like, have you stumbled upon anything like in that, like, can I remap the string concept in a new language?
Remap the string.
Right,
concept in
whatever
any
word
language.
you know, node, or some
Oh,
operation,
like you
some
mean
operation.
learning the new words in a
Right,
new language.
and the difficulty of remapping concepts when learning new languages.
So that's not something I spent a lot of time on, but actually that splashy paper from yesterday that I cited does at least touches on that. So check that out, and they've got lots of references.
Let's thank the speaker again.